Cool. All of Jazz Choir is watching this stream. Oh, feel bad for the non-calculus students in Jazz Choir. We'll see how many people we actually get in here. It is a bit of a weird time, and the SAT was this weekend. Might be a lighter live audience. Hello, Anna from UW. I'm confused, but word. Oh, all right. Well, I told people they could email me if they wanted to ask me any questions that maybe the live people wouldn't ask me, and nobody emailed me, so I am relying entirely upon live questions to figure out where to go. Oh, good. Of the 4 or 5 people watching, 3 of them are me or former students. Oops. That's probably not going to send us in a useful direction. Huh. Well, it is 1 p.m., so guess I can start this. Usually I have a direction I want to go, and the direction I'm probably going to start with, if I had to choose something, would be to go over the bottom 2 AP questions, because I only went over the first one in class, so there would be value in that. And actually, I want to zoom in on it. Cool. So in the second question, this is a really big thinking question, and there's very, 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 very little math in this question, and lots of terms and thinking. So for the first part, it says, using appropriate units, explain the meaning of this integral right here in terms of the car's motion. And the way to describe that is the integral of velocity is position, and the integral of the absolute value of velocity, okay, so the integral of velocity would give you a change in position, because it's a definite integral. It tells you how much it changed from 30 to 60. But because we're integrating the absolute value, we're actually going to get a total distance traveled by the car. One of the ways I like to think about this is if you're here and your friend's house is here, and you drive to your friend's house, and then you drive back. If you didn't have the absolute value, the answer for this would be 0, because the position at the beginning and the position at the end would be the same. However, if you put the absolute value around the velocity, then you actually account for the fact that you traveled there and traveled back, and so you had a decent amount of distance traveled there. So, yeah, we have to say the distance traveled in feet from 30 to 60 seconds. I guess I could have said traveled by the car. I'm not sure. I don't think that would lose any points, though, not specifying it. The big part is that you use feet and seconds in your answer to be as specific as possible with the units. All right, then it says approximate the integral using the 3 subintervals in the table. This is 30 to 60 right here. And so since we're absolute valuing, this is 14, 10, 0, and 10. And I just do trap sums with this. So the first one has an average height of 12 times 5. Plus the second one has an average height of 5 times 15. And the next one has also an average height of 5 between 0 and 10. So plus 5 times 10. And so we get 50 plus 75 is 125 plus 60 is 185. And most people I saw getting that correctly. Now, I do need to remember units, so feet. All right, second one. Using appropriate units, explain the meaning of this integral. Is it the integral from 0 to 30 of a of t dt in terms of the car's motion? The integral from 0 to 30 of a to t dt is the change in velocity. Just like this was in our first integral, it was the change of position because we were integrating velocity. When we integrate acceleration, we get velocity, so it's a change in velocity from 0 to 30 seconds. So the change in velocity from 0 to 30 seconds. And I have to put my units here, feet per second. And then find the exact value of the change in velocity. Well, it's just I take the velocity at 30 and at 0 and I subtract them and it's equal to 6, because that's what negative 14 minus 20 is. You're going up 6 from negative 20 to negative 14. All right, those are the two like kind of easy ones. The explanations, I think, are harder than the actual math parts of those two questions. The next one is pretty family friendly. It just asks, where is the velocity equal to negative 5? Or must there be a time? And it's pretty easy to go, yeah, it's negative 10 at 35, it's 0 at 50. So, continuous. So I need to say the function's continuous for the intermediate value theorem to work, and they tell me in the function, or in the problem, it's continuous. So it's continuous, so IVT guarantees on 35 to 50. I think this is the laziest possible way to write this. Yeah. You need to say it's continuous, you need to mention the intermediate value theorem, and you need to say the interval on which it is guaranteed. Alright, for D, it says, must there be a time when a of t equals 0? And this is a trickier question, because if you look at A, it's like, no, 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 we're always positive with A. But that's not good enough, because these are just a bunch of snapshots of what the acceleration looks like. It could definitely dip down to a negative value in between any of those values. And so we have to go and look at the integral of the acceleration, the velocity, to see if the average rate of change ever, which is acceleration, average acceleration, is ever 0. Because if the average change in the velocity is ever 0, then the acceleration must be 0 once on that interval. And so we just look through this table and we're like, oh crap, it's the same in two different places. And the mean value theorem guarantees that if the average rate of change is 0, the instantaneous rate of change must be 0. So this is where we use the mean value theorem. So it's continuous. And the mean value theorem guarantees at least one value on 0 to 25. And that's kind of the big idea. On the actual AP test, make sure you show your math so they know what you're thinking, so you're not just swinging it. Like, here's the average rate of change, and that equals 0, wow. And so now it definitely guarantees. And that's that question. Hopefully that's helpful to the people who are watching later, since there's almost no one here right now. Can you review cross-sections? No, I can't, because that's not on this test. So I guess I'll continue doing these free response questions. The next one's quite a bit shorter. There's only an a and a b. So here we have a function, its derivative, and its second derivative. And then we get something completely different. We get that g equals e to the ax plus f of x for all real numbers. And a is a constant, so it's just the x that's a variable. And we're supposed to find g prime of 0 and g double prime of 0 in terms of a. So this is a great review of exponentials. It's just, you just take a bunch of exponential derivatives. G prime of x equals e to the ax times a. That's rewrite chain rule times natural log of the base, but natural log of e is 1. Then we take the derivative of f of x and we get f prime of x. Cool. And there's g prime of x. Then I just plug in 0 for x, and so that makes this 1. This is a. And f prime of x, f prime of 0, is negative 4. So this is just a minus 4. And that's a prime. All right, g double prime of x. I have to take a derivative of this. I get e to the ax times a times another a, because I chain out another a. And so it's really an a squared there. And plus f double prime of x. No chain rule here. And then we just plug in values. So we're going to have a 3 here. And then if I plug 0 into this, I just get a squared. And so I get a squared plus 3. And that's it for that. All right. Now that's A. Let's do B. Okay, so in B it says there's a function h of x that equals cosine of kx times f of x. We're supposed to find h prime of x and write the equation for a line tangent. So let's just find h prime right now. We got a little bit of product rule here. So the derivative of cosine is negative sine of kx. And we chain out a k. And so that's just a prime times b plus a times b prime. Sick. That is the derivative. Alright, now I have to find the line tangent at x equals 0, so I'm going to have to plug 0 into this. Sine of 0 is 0, so this term does not matter. Cosine of 0 is 1, so this term does matter. But f prime of x was negative 4, f prime of 0 was negative 4. So this is just 1 times negative 4 for my h prime, my slope. And so I get negative 4 for my slope. Cool. That's not good enough, though, because we don't just want h prime. We also need to find h of x, because we're trying to find a tangent line. And when you're trying to find a tangent line, you need two things. You need a point and a slope. So we found the slope. Cool. Now let's find the point. By plugging 0 in here, we get 1 times f of 0, which is 2. Cool. So 0, 2 is my point. And then you just dump it in point slope form. Although here, because we're given the y-intercept, we can just put it in slope-intercept form. It's negative 4x plus 2. Wow. TJ buddy, that was the last test. Properties of integral, second fundamental theorem. But good effort. Feels bad when your review stream is more attended by kids not in your class. Alright, that was a big thing I wanted to go over. Because those are tricky, and people may want to see those. I was hoping I would get some questions on this review, like maybe something, but it appears that is not the case. The good news is, if we wrap this stream up early, I can just post last year's stream and say, hey, if you want to watch this one, you can see 14 minutes of me doing free response problems. But if you want to see more multiple choice, you gotta watch last year's stream. Kind of leaning that direction at this point. This is the worst attendance I've had ever. That's what I get for making it in the middle of the day. Oops. Do you want me to ask questions? If you have questions, I would love if you ask them. Yes, please, Drew. You're actually in this class, unlike most of the people in my chat. Just do problems you think are hard. I don't really think any of these are that hard. That's not very helpful for me. Because 7's a little involved, but it's not. It's the factoring's hard. You don't have any questions, but you don't want the stream to end. Conundrum. I could look at 7. 7's a trickier question on here, and I know this guy. So, if we were to do 7, it says, determine where this function satisfies the mean value theorem on the interval 0 to 1. Or determine if it does. So, we have to take a derivative. Actually, do we have to take a derivative right away? No. Let's mean value theorem this. Let's just plug in 1 and 0 and see what we get. So if we plug in 1, we get 1 plus 1 times 0. Wow, that was easy. That was 1. So this goes through 1, 1. If I plug in 0, I get 0 plus 0. Cool. So it goes through 0, 0. So I know the average slope between 0, 0 and 1, 1 is 1. Cool. Now, I need to see if that ever equals the instantaneous slope. This thing is continuous, so it should have a value where the average slope matches the instantaneous slope. Like, there's no continuity problem on this interval. We're allowed to take the cubed root of 0. We're allowed to take the cubed root of negative or positive. Here, same issue. Cubed root, you can plug in anything. So, yeah, we gotta set 1 equal to the derivative of this, so I'm gonna take that. 1 plus a prime b plus a b prime sick. All right. Now I gotta see where these are equal. Well, cool, the 1s on either side, those go away. And now this remaining garbage here, the route I kind of want to take on this is, wait, did I forget to write? Oh, I forgot to write a prime b. Here, there's a b here that I forgot to write. Look at that beautiful thing. And actually, can I go with like a big, yeah, just made room for myself. All right. So I'll just rewrite this crap since I wrote it wrong initially by forgetting my b. Cool. This requires some factoring to simplify this guy to an acceptable threshold. And the factoring I'm going to do is to take out the negative powers for both of them, because that'll leave me with only whole number powers on the inside. So if I take out the negative powers, like factoring, take out, I get x to the negative 1/3 and 1 minus x to the negative 2/3. And in my leftover parenthesis, I have a 2/3 for over in the original part there. And then the negative 1/3 goes away completely, and if I divide 1 minus x to the 1/3 by 1 minus x to the negative 2/3, I just get 1 minus x. And that's pretty interesting. That's very simple. And then in my second term, if I take if I divide it here, the 1 minus x to the negative 2/3 will go away completely. I'll get a 1/3 from here, and then x to the 2/3 divided by x to the negative 1/3 is just x. All right, these are irrelevant. This has a critical point of 0. This has a critical point of 1. I want it on the interval, not at the endpoints. So all I care about is the last parentheses here. So I'm just going to solve this for where it's equal to 0. And I get 2/3 minus 2/3 x plus 1/3 x. And I want where that equals 0. So this is just 1/3 x equals 2/3. X equals 2. Oh, sad panda. Can I do that on the test if I don't know how to do a problem? Yeah. I'm pretty sure I want to get 1/2, so I'm a little mystified as to what the demon magic I did to get to this point. So I'm going to blame Drew for bullying me into doing this problem I didn't even need to do. I'm sure in my answer key it has correct work. I forgot a negative sign somewhere. Oh yeah, because I'm really good at chain ruling. I had to chain rule out a -1 here. And that makes this times -1. It turns this into a negative, makes that subtracting, and I don't get 1/3 x equals 2/3, I get x equals 2/3, which is absolutely correct. If you're curious how I knew x equals 2 is wrong, it's because it's not on the interval 0 to 1, and I know that there's a value that satisfies this equation on the interval. And so it's just booyah, it has to be e, where x equals 2/3, or where c equals 2/3. And that's a brutal question, because the factoring is freaking horrible, but the calculus for that question is pretty easy. It's just, once you get to this, after this calculus step here, it's a disaster and things fall apart. I actually don't remember how to do 14. Talk about the possibility of Jay Inslee winning the primary. Anyone can win the lottery. All you have to do is play. Is there a 14 on here? Oh. Yeah, 14's a good question. Good direction, Tribble. So 14 is an inverse function question. And if you're super good at inverse functions, you know 1 over f prime of g of x equals g prime of x, where g is the inverse function. So all we have to do is find f prime. And they give us f. So f prime of x equals 2x plus secant squared pi x over 2 times pi over 2 for the chain rule. And then you just have to plug g of 6 into the function. And to find g of 6, which is the tricky part, however, they give us this fat hint here, so it's not going to be that tricky. We plug 6 in for f of x, and the x value in the original function at an output of 6 is the output of our inverse. So that hint in the question is just telling you that x is going to be 0, which you can tell when you set these equal, because if these cancel, then you get 0 equals x squared plus tangent pi x over 2. And where is that true? Well, tangent is 0 at 0, and so is x squared. So, the moral of the story is it's x equals 0. So all we're going to have to do for this 1 over f prime of g of x is do 1 over f prime of 0. And that's really easy, because secant of 0 is the same thing as cosine of 0, because cosine of 0 is 1. So secant squared of 0 is also 1. And so this is just 1 over pi over 2, or 2 over pi, which is a. What answer should you guess on multiple choice questions if you don't know the answer? I don't know, guess, dude. I definitely don't balance out my A, B, C, and D on my tests. So if you guess the 1 in 5 or 4 really lucky, then you could do better or worse than average. I don't see the point of balancing this, because there's like your probability chance is still equal on any question. So yeah, guessing is guessing. Yeah, I don't know. The rest of these are just like basic U-sub questions. I don't really know what people would find difficult. So I'm struggling with motivation. I guess I'll do 8 down here, because I can see people stumbling on 8 because they don't think back to the very beginning of the year. Because you might look at this and be like, wow, this kind of looks like inverse secant. But no. If inverse secant, if you integrate something that kind of looks like this, but this is a derivative. And so this is something completely different. So if you just rewrite this as 13 times x minus 2 to some power, where you combine the powers on the bottom, 0.5 and 1.1, and you get negative 1.6, then this is a really, really easy question. It's 13 times negative 1.6 times x minus 2 to the negative 2.6. And that's it. And I'm like too lazy to even multiply this. What, 208 or something? So 20.8 times x minus 2 to the negative 2.6, whatever, this is fine. Yeah. Well, we're up to 8 people watching, and I'm pretty sure like 6 of them are from last year. So that's a big yikes. They don't have any questions, except for Tribble's question on the inverse. That was a good choice to retract that question, Drew. How is my, I don't know, ask her. You can look at her quizzes. I'm not gonna like call her out on the freaking internet for her quiz scores. That does not seem cool. Differential equations is next unit. Oh, Timothy's slightly confused on question 5 on here? Oh yeah. I wonder how many times you retook this quiz last year. Because this is a very commonly botched quiz. If you have the integral from b to a and the integral from a to b, you just throw a negative on one of these to make it so that their bounds match up. So I put the negative here and swapped these bounds. So this is negative 13. And then you just integrate x cubed separately. It's x to the 4th over 4. Plug your bounds in. You get a to the 4th over 4 minus b to the 4th over 4. And then f of x integral is just this, minus 13. Done. Wow. So the key is to treat these as 2 separate integrals, where f of x gives you a negative 13 just straight up, because it like tells you in this part of the problem what it's going to be. And then x cubed, we actually have to do the old-fashioned way. Properties of integrals are on every test because I like do cumulative stuff in this class. Yeah. Yeah, so between this stream and last stream, there should be enough information on logarithms. I'll also post last year's live stream because people asked me more questions then. I'm imagining we're going to see some pretty train wrecky scores this time around because a lot of people have been sloughing this unit. And yeah, this is a bad unit to not try during because you don't know how to use the rules. And then you try to memorize them before the test, and then you use them for the wrong problems, and yeah. I'm worried about the cohort coming in here. I hope enough people are able to see stuff, to practice stuff, to do better, but what I'm seeing in class is that this is going to be a unfortunate test, and it has very little to do with the material and more to do with the snow and then people's desire to actually work hard to make up the gap. So are there going to be optimization problems on the test? Maybe. I usually tell people, unless we're in the unit, optimization's like a 30 to 40% chance. Related rates is like 60 to 70% chance. There are just more related rates on the AP test than there are optimization questions. So, related rates is more important. That's why we spent more days on it and stuff. But anyways, have a nice afternoon. I'll be posting both review streams, so if you really wanted to see more than was in this one, you can look at last year's. People asked me more questions. I probably went over some more crap. I probably got that one question wrong when I went over it last year too, because I always forget to chain rule out that -1. Don't do that. Don't be like me. Alright. That was short. Well, yeah, nobody's asking me any questions. I'm not gonna like do random crap. Like I already did a review stream like 2 weeks ago, so I did like most of the exponential stuff. I don't know, man. This is meant to be kind of short, and it's shorter than I imagined because fewer people showed up than I thought. Well, hold up. Can you do some math? Of course I can do math. Come on, man. I had some L'Hôpitals ready. Like, I guess we already did those. Do I have any ones we didn't do? Yeah, these ones. And these are hairy. Is there a shorthand for nested functions? No. Usually you don't nest that deeply, and if you do, I feel bad for you. So hyperbolic sine, no, get the heck out. That one's definitely not happening. This one has no obvious numerator or denominator, so that's an easy rule out. Let's get rid of that one. And yeah, 14 looks like a good question. 14 looks like one where we can actually, that's a reasonable thing to ask you. 13 also is pretty reasonable. So if we look at, yeah, these ones are horrible in this 10, 11, 12. There's a reason they weren't on your worksheet. All right. So if we have cotangent of x over natural log of x, cotangent is cosine over sine. And if we divide by 0, okay, so at 0, cosine is 1 and sine is 0, but if from the positive side, it's a positive close to 0 number, which means this is going to infinity on top, and on the bottom, when we plug in 0 from the positive side, we're going to negative infinity. And so this is a classic L'Hôpital's case where we have indeterminate over indeterminate. And so the way I determine this is to L'Hopital's, and let's see if this works out. Negative cosecant squared x and 1 over x are our derivatives. I don't want to look at these because they're both 1 overs. Cosecant's just 1 over sine. So I'm going to call this a sine squared on the bottom. I guess I got to put a negative out front for this negative. And an x on the top. And then I plug 0 in now, and I get 0 over 0. And I'm like, crap, this is another L'Hopital's case. This was infinity over infinity, and our after L'Hopital's were 0 over 0, but we still don't know what's going on. So I do another derivative, and I get negative 1 on top for the derivative of negative x, and I get 2 sine x cosine x on the bottom for the derivative of sine squared x. And now our top is definitely determinate. Our bottom is still 0. And so we're a bit sad because, you know, this is 1, this is 2, and this is like a little tiny positive number. And so since we have negative 1 over a little tiny positive number, this is going to be going to negative infinity. That's a really hard L'Hopital's problem. Wow. Yeah, we had to take 2 derivatives. It was like hard to evaluate. Yeah. L'Hopital's got us there, but not cleanly. I don't know if anybody really wants to see any more of these. I guess I could do 15. 15 doesn't look hard. Let's see if it isn't. If I plug in infinity, I get infinity over infinity. Cool, let's go L'Hopital's. I get 1 plus cosine of 2x times 2 over 1. And then I just plug in infinity, and I get cosine of 2x times 2 at infinity is just something doing this at infinity. And that's pretty whack. And this thing goes to 1 at infinity, because so yeah, this ultimately isn't very helpful because we still end up with indeterminate in our L'Hopital's, and so this is a case where L'Hopital's is garbage. If you just evaluate this the old-fashioned way, which unfortunately is how you have to evaluate a bunch of functions, L'Hopital's is a shortcut people think is like infallible, but it's like really fallible. And in this case, like, we got something where it's like the top goes between negative 1 and 1, and the bottom is 1, and that sucks. And yeah, this doesn't tell us anything. However, we could have just looked at this at the beginning and said, hey, if I put in a million over a million, and I add like 1 or negative 1, or add 1 or subtract 1, this is like an or, it's really not going to do much. This is just going to go to 1. And so I didn't need L'Hopital's for this. L'Hopital's was profoundly unhelpful. So just be aware that L'Hopital's is not an infallible tool. It can be really, really helpful. It's really awesome when there's something that you can factor out of the top or bottom, and it's like a 0 over 0 case. Or if you don't remember which parent function is bigger than which, you can use L'Hopital to take the derivative top and bottom until it actually works out. But please do not think L'Hopital is infallible. All right. That was some L'Hopital talk because that was actually on this test. And yeah, I'm officially pretty tired because I only got like 5 hours of sleep because I played video games for like 15 hours and my finger hurt, so this rest was really nice. But yeah, hopefully you learned some math or you had some fun, and I wish you all the best of luck and happy trails on your weekend. Bye-bye.